In this little segment, we're just going to give a quick overview of the different components of the ISET simulation pipe. We're going to start by just saying a few words about the scene.
And showing some examples of different scenes.
And then we're going to talk about how the optics transforms the scene, which is a spectral radiance, and the optics transforms it into spectral irradiance. And the spectral irradiance falls at the sensor. Once it's absorbed by the sensor, it's processed
by the image processing pipeline and then rendered for a particular display. And we can also model the display. We'll show you how you can do that as well.
So the scene representation, the spectral radiance is representation, has units of photons per second, per nanometer, per steradian, per square meter. And every point in this image is represented in the software by the full spectral radiance.
Right, and then the scene falls on to the sensor surface, so we want to be able to describe the irradiance, that's the energy that's falling on the sensor, and we describe that in terms of photons per second, per nanometer, per meter squared, and again, that's the irradiance, the energy that's falling on the sensor.
And it's the optics that transform the scene radiance to the optical irradiance at the sensor surface.
And then at the sensor, we can model how those photons are absorbed by each of the pixels, and that's going to be determined by such things as the spectral filter that's falling on top of that pixel, and other properties such as the noise, and we modeled then how
the size of the pixel or spatial arrangements, many things. Those are all modeled.
Exposure duration, that allows you to calculate how many electrons are generated at each of the pixels.
And the general sensor properties are modeled by the parameters shown at this side of the image, and the individual pixel properties are modeled by the parameters on this side. These information panels here at the top of each script tell you summary statistics about the way, in this case, the way the sensor is capturing data. The next major window is the processing window, which converts the electrons in the sensor into digital values that you then go ahead and display on your display device.
Right, and for the case of a digital camera, that will include things that you will explain later, demosaicing, color balancing, image enhancement.
Also, people think of cameras as going to one display, but usually cameras go to a couple of displays, and they go to the little viewfinder display, they go to a projector, they go to all kinds of different places. And so being able to model how what the output will look like on those different types of displays is another piece of value that you get from the image system simulation.